Good morning, students. Myself, Deepa Deshnoor, and this is our physics class. In my first lecture, we had started the topic optics, and in that, we discussed the introduction part that includes what is optics, into how many branches the optics is categorized, what is reflection, laws of reflection, and about spherical reflecting surfaces. Means how the spherical reflecting surfaces are formed. They are nothing but the mirrors. How the mirrors are formed, and some important terms related to mirror, that is aperture, pole, principal axis, principal focus. These all things we studied in our first lecture. Now in this class we study the continuation part of that, the continuation part in the optics, that is sign convention. Now what is sign convention and for what reason it is necessary, we'll see in this class. The sign convention means if we are having a mirror, we draw the principal axis and we have kept an object AB in front of the mirror. So the distance at which the object is placed in front of the mirror is called as object distance. Fine, but from which point of the mirror the measurement has to be taken? The question is from which point of the mirror the measurement has to be taken, and how the measurement has to be taken, whether it has to be taken positive or negative. Now these all points are given by the sign convention, the 3 points of sign convention. According to the first point of sign convention, all distances are measured from the pole of the mirror along the principal axis. From the pole of the mirror along the principal axis. It means here is our pole of the mirror. We have to measure the object distance from the pole towards the object. From the pole towards the object. If it is something like 5 centimeter, we can say object is at a 5 centimeter. This is not permitted. You cannot measure in this way. The measurement has to be taken along the principal axis. Then, if the principal focus is here, so the distance from the pole to the principal focus is taken as focal length. Again, the measurement we are taking from the pole. So whether it is a object distance, whether it is a principal, whether it is a focal length, whether it is a radius of curvature, all the measurements have to be taken from the pole of the mirror along the principal axis. Then second point is the distances measured along the direction of incident light are taken positive and distances measured opposite to the incident light direction are taken negative. It means we have kept an object AB in front of the mirror. Then the light rays from the object are going to incident on the mirror. So this is the direction of the incident ray towards the right. So what is the direction of the incident ray? Towards the right. So according to this diagram, we can say the measurements taken towards the right are taken positive. The measurement taken towards the left are taken negative. So object distance, how you are measuring? From the pole to the object, which is towards the left, which is opposite to the incident ray, So your object distance becomes a negative -5. So the object is at a distance of 5 centimeter from the pole. How we are measuring the object distance? In the opposite direction that of the incident ray, because incident ray is towards the right. Our direction of measurement from the pole to the object is towards the left, so the measurement has to be taken negative. If suppose If suppose the object is formed behind the mirror, assume. So in the next portion you are going to see what is the image formation behind the mirror and about virtual image. For time being, you just assume the image is formed behind the behind the mirror. Now according to the first point, how we are going to measure the image distance from the pole to the image? Your image is a dash b dash. How you are going to measure the image distance from the pole towards the image along the principal axis? That is p b dash. P b dash, if it is something like 2 centimeter. Now what is the direction of the measurement from the pole to b dash? From the pole to b dash towards the right, which is in the direction of the incident ray, then this measurement can be taken as positive. So your image distance become +2. This is just an example. If suppose the image is formed in front of the mirror, below the principal axis, then how the image distance has to be measured? From the pole to the image, p b dash. From the pole to the image, p b dash. If it is 2 centimeter, look at the direction of the measurement. P b dash is towards the left. Our incident ray is towards the right. Again, our direction of measurement is opposite to the incident ray. Then the measurement has to be taken negative. Your image distance becomes -2. Now let us see. If here is the principal focus, now how we are going to measure the focal length? Always from the pole. So from the pole to f, pf will be our focal length. What about the sign, minus or plus? We are measuring the focal length from pole to principal focus towards left, which is opposite to the incident light, which is towards right. So your focal length can be taken as minus, because the measurement is opposite to the direction of the incident ray. So this is all about the sign given to the measured distances. Now the third point is heights measured above the principal axis are taken positive and below the principal axis are taken negative. Now look at the object AB. It is above the principal axis. If it is of height h, then it can be taken as +h. Now look at the image A dash B dash, which is inverted below the principal axis. If it is of height h dash, then it can be taken as -h dash, as it is below the principal axis. Now why this sign convention is required? It is required for the derivation purpose as well as for the calculations and to solve the numericals. Now we'll move on to the next concept, that is nothing but image formation. We'll see how the images are formed and what is an image. Here you can refer to the diagram. We have taken a concave mirror. And there is an object AB placed in front of the mirror. So from the object AB, number of rays will be getting emitted. They all will be incident on the mirror and get reflected. After reflection, wherever they meet, wherever all these rays meet, so that is the image formation point. That is nothing but our image of the object AB. But for our convenience, we are taking the rays getting emerged from point A. For our convenience, we are taking the rays getting emerged only from A. And that too, we are considering only 3 rays. It doesn't mean that only 3 rays will get emitted from point A. So, if the 3 rays are getting emitted from point A, after a reflection, wherever all these 3 reflected rays meet, that gives the image A dash corresponding to the point A of the object. So wherever the reflected rays from the point A meet, gives you the image A dash of the point A. Image A dash corresponding to the point A. Thus we can say image is a point to point correspondence. Image is a point to point correspondence with the object. How this correspondence has established? This is established through the reflection. For example, if you take any intermediate point Z on the object, then all the rays getting emitted from point Z will be incident on the mirror. After reflection, wherever those reflected rays meet, that forms the image of the point Z. That forms the image of the point Z. If the rays getting emitted from point B, if the rays getting emitted from point B after reflection, wherever they meet, wherever they all reflected rays meet, gives you the image B dash of the point B. So we can say image is a point to point correspondence with the object established through the reflection. In case of lenses, the same thing we can say, but that is established through the refraction. So in case of lens, we can say image is a point to point correspondence with the object established through the refraction. Here in case of mirror, it is established through the reflection. Now, as I have already told, there are number of rays will be getting emitted from a single point of the object, and wherever they meet, it is going to be form a image of that point. But we cannot represent all the rays diagrammatically. So for our convenience, we can choose the 3 rays. We can choose the 3 rays to represent the image formation in the diagram. To represent the image formation in the diagram. Now, which are those 3 rays that we can consider? The first one is the ray parallel to the principal axis after reflection passes through the principal focus. After reflection passes through the principal focus. It is nothing but the definition of the principal focus. So here from the object, the ray AM is parallel to the principal axis. So after reflection, it is passing through the principal focus MFD. It is passing through the principal focus. The second ray that we can consider is, if the ray passes through the center of curvature, then the reflected ray simply retraces its path. It goes back in the same direction. So, which is the ray that passes through the center of curvature? It is ACN. The ray emitted from point A is traveling through C. ACN is the ray passing through the center of curvature, which retraces its path. That is NCA. It retraces its path along NCA. And the third ray that we can consider for the image formation is, it is inverse of point 1, inverse of the first ray. That is the ray passing through the focus after reflection becomes parallel to the principal axis. the ray passing through the focus after reflection becomes parallel to the principal axis. So which is that third ray? AFX. AFX is the ray, incident ray, which is passing through the principal focus. So after reflection, it becomes parallel to the principal axis, X, A dash, Y. Now look at all these three reflected rays. MFD, the reflected first ray, NCA, second reflected ray, X, A dash, Y, the third reflected ray. All these three are meeting at the point A dash. All these three are meeting at one point, and that we can represent as A dash because it is the correspondence to the point A of the object. So there you can form the image A dash, B dash, A dash, B dash. This is how we can represent the image formation diagrammatically by a mirror, maybe a concave mirror or maybe a convex mirror. Now we'll see the image formation by concave mirror as well as convex mirror for the different object distances. So for that, here we have a concave mirror. Our first job is to draw the principal axis, then name the points like pole, principal focus F, center of curvature C. So the first object distance that we are taking is beyond C. Here the principal axis is divided into some parts like principal focus, center of curvature and far away infinity. The object can be placed at infinity, beyond C, at C, between C and F, at F and within F. So these all are the possible distances where the object can be placed. In that, the first one we shall see the image formed by an object placed beyond C. For that, we can consider any two rays among these three. I will consider the first and the third one. Now we shall draw the first ray. That is, this is our object AB. The first ray is parallel to the principal axis. Now after reflection, this ray passes through the principal focus. The second one, another ray I can consider for image formation is the ray which passes through the principal focus, the incident ray which passes through the principal focus after reflection becomes parallel to the principal axis. After reflection becomes parallel to the principal axis. Now let me show the direction. This is the first incident ray at M, the reflected ray. This is the second incident ray at N and the reflected ray. Look at these two reflected rays. They are meeting at this point, which represent the point A dash, image of point A. So we can draw the image A dash, B dash. So we can draw the image A dash, B dash. Now look at the nature of the image. As it is below the principal axis, it is inverted. as it is in front of the mirror, which is formed by the actual meeting of the reflected ray. The reflected ray have actually meeting to form the image. So it is called as real image. If the image is in front of the mirror, the image is called as real image. And look at the size of the image compared to the object. It is smaller than that of the object. So you can say object is diminished. Collectively, you can describe the nature of the image as real, inverted and diminished, where the image is formed between C and F. So for the object beyond C, the image is formed between C and F. Now we'll move on to the image formation by the concave mirror, whereas we are considering the object is placed at C. We are considering the object placed at C. Again, we can consider the two rays for the image formation. The first one I can consider is, your first job is to draw the mirror, to mark the important points, that is such as pole, principal focus and center of curvature. Now I'll take the first incident ray, which is parallel to the principal axis. Parallel to the principal axis. If the ray is parallel to the principal axis, after reflection it passes through the principal focus. The second ray I can consider is the incident ray passing through the principal focus. So after reflection it becomes parallel to the principal axis. So after reflection it becomes parallel to the principal axis. Now let me show the directions. This is our object AB. The incident ray, first incident ray at AM, and first reflected ray is passing through principal focus. Second incident ray AN, after reflection it is becoming parallel to the principal axis. So here is the point where they are meeting. Here the two reflected rays are meeting, which gives you the image A dash of the point A. So you can draw the image A dash B dash. You can draw the image A dash B dash. Now we shall describe the nature of the image. Again, the image is formed below the principal axis. You can say image is inverted as it is formed in front of the mirror. It is real. And look at the size of the image. It is of the same size that of the object. It is of same size that of the object. So collectively you can say image is real, inverted and of same size that of the object. Now where the image is formed at the point C, so center of curvature is the point where object and images are formed. So this is the same point where you can get the object as well as image. Both will be of a same height. Next we shall see the image formation by the concave mirror when the object is placed between C and F. Between C and F. For that, first ray I can draw is parallel to principal axis. Parallel to principal axis. After reflection, it passes through principal focus. It passes through principal focus. The second ray I can consider is passing through the principal focus. Passing through principal focus. After reflection, it becomes parallel to the principal axis. After reflection, it becomes parallel to the principal axis. So from B to M is our incident ray. After reflection, it is passing through the focus MF. B to N is our second incident ray, which is passing through the focus. After reflection, it becomes parallel to the principal axis. So wherever these two reflected rays meet, it forms the image. It is B dash A dash. B dash A dash. Now we'll describe the nature of the image. The image is below the principal axis. It is inverted as it is in front of the mirror, or it is formed by actual meeting of the reflected ray. The image is formed by actual meeting of the reflected ray. It is called as real image. And look at the size of the image compared to the object. So compared to the object AB, the image A dash B dash is of larger size, a little bit larger size. So you can say the image is magnified. The image is magnified. So collectively you can say the image is real, inverted and magnified. Now where the image is formed? For the object between C and F, image is formed beyond C. Now we'll see the image formation for convex mirror. So in the introduction part, you have studied that what type of a mirror it is. Convex mirror, it diverges the rays. It means after reflection, the reflected rays never meet. After reflection, the reflected rays never meet because this mirror diverges the rays which falls on it. Again, according to our rays of image formation, we shall consider any two rays among the three. So the first one we shall consider is the ray parallel to the principal axis. So the ray parallel to the principal axis. So according to the definition of principal focus of the convex mirror, how it is defined? So when a paraxial ray is incident on a convex mirror, the ray get reflected. How it gets reflected? It reflects as if its direction of reflection is extrapolated in the backward direction. It meets at the principal focus. So how it gets reflected? Its direction of reflection. When it is extrapolated meets at F. See, this is our object AB. It is incident at point M. So the incident ray AM get reflects in the direction MX. It gets diverged. But how it get reflected? The parallel incident ray AM, how it get reflected? When its direction of reflection extrapolated in the backward direction. When the reflected ray is extrapolated in the backward direction, it meets at F. The second ray that we can consider is the ray which passes through the center of curvature. So in case of convex mirror, the ray actually cannot pass through the center of curvature because it is inside the mirror and the ray is outside the mirror. So the incident ray cannot pass through the center of curvature actually, but the direction of the incident ray can be along the center of curvature. So the direction of incident ray is along the center of curvature. So the second ray I can consider is the incident ray from point A is incident on the convex mirror in the direction which joins the center of curvature. So the incident ray which passes through means it's a direction of incident ray passes through the center of curvature. So it's a direction of incident ray passes through the center of curvature, then such a incident ray retraces its path. So this is our incident ray, as well as the same will be our reflected ray. So the first reflected ray mx. Let us take the second incident ray as an. So the second incident ray an reflects along NA, retraces its path, and the first reflected ray mx. So these two reflected rays actually never meet, but when you extrapolate them in the backward direction, they meet at a certain point. So for an observer, the two reflected rays appear as if they are coming from this point. The two reflected rays appear as if they are coming from the point where they appear. They are meeting at that point. Actually, they are not meeting at that point. They are not meeting at point A dash. They appear as if the reflected rays are meeting at point A dash. They are emerging at point A dash, emerging from the point A dash. So A dash represents the image of point A. It is a virtual point. The rays are not actually meeting. So that is, they appear as if they are diverging from that point. So A dash is a virtual image of the point A, and A dash B dash you can represent as the virtual image of the object AB. So let us describe the nature of the image now. The image is above the principal axis. So you can say image is erect. The image is behind the mirror, or else you can say the image is not formed due to the actual meeting of the rays. Image is not formed due to the actual meeting of the image. So because of that reason, it is called as virtual image. Now look at the size of the image. It is smaller than the object. So collectively you can say image formed by the convex mirror is erect, virtual and diminished. So for any object distance in case of convex mirror, the image is always diminished, but not in case of concave mirror. Sometimes the image is diminished, sometimes the image is of same size, sometimes the image is magnified. It all depend upon the object distance, where the object is placed. But in case of convex mirror, the image is always diminished. The image formed by the convex mirror is always diminished. Now we'll see the image formed by concave mirror when the object is placed within focal length. So far we have seen the image formed by concave mirror when the object is beyond C, at C, and between C and F. Now we'll see the image formation by the concave mirror when the object is between F and C, between F and C. Sorry, between F and pole. So again, here we can consider the two rays among the three. First I can consider is parallel to the principal axis. The first ray that I can consider is parallel to the principal axis. So after reflection, it passes through the principal focus. After reflection, it passes through the principal focus. So the direction of incident ray is AM. This is my object AB. The incident ray is AM and the reflected ray is MF, which is passing through the principal focus. So the second ray that I can consider is the ray passing through the C. The ray passing through the C means it has to be incident on the mirror in the direction of C. The ray has to be incident on the mirror along the direction of C. See, if the ray from A to N is incident on the mirror at point N, it retraces its path because the direction of the incident ray AN is along the C. So any ray which is in the direction A to N retraces its path. Now look at these two reflected rays. Do you feel they are going to meet each other? No, they seems to be diverging from each other. They never meet. Then how the image is going to be formed? Then the reflected rays appear as if they are getting emitted from this point. The reflected rays appear as if they are getting emitted from this point. So where I can get the image A dash B dash. So when you extrapolate the reflected rays NA and MF in the backward direction, they meet at a point behind the mirror which can be named as A dash, which represents the virtual image of the point A. Why it is virtual? Because the reflected rays appear as if they are coming from point A. The reflected rays MF and NC, they appear as if both together are coming from point A dash. So A dash is called as the virtual image of point A. Now we shall describe the nature of the image, how the image is. It is erect as it is above the principal axis. The image is erect as it is behind the mirror, or you can say it is not formed due to the actual meeting of the reflected rays. It is not formed due to the actual meeting of the rays. You can say it is virtual. Look at the size of the image compared to the object. It is of larger size than the object. Then you can say image is magnified. So collectively you can say image is erect, virtual and magnified. So when, even though concave mirror is called as converging mirror, if the object is placed within the focal length, the reflected rays diverge. They actually are not going to meet to form the real image. So a virtual image, virtual magnified image is going to be formed by a concave mirror. Now where such a mirrors are used? In case of makeup kit, a small concave mirror is used. That is what you cannot see your erect image. Otherwise it would have been erect image of your face if the object is greater than the focal length. You hold that mirror nearer to your face so that the distance between your face and the pole of that makeup kit mirror is less than the focal length, because of that you can see the erect magnified image of your face, not the inverted one, because the distance is less than focal length. Now we shall see the list of the object and image formed, the object distance and corresponding image formed by the concave mirror. The first one is, in case of concave mirror, if the object is placed at infinity, image is going to be formed at principal focus, which will be real, inverted and diminished. So object at infinity means the rays coming from that object after traveling a long infinite distance becomes parallel to each other. Now when these parallel rays are incident on a mirror, obviously they are going to meet at principal focus according to the definition of principal focus. So when the parallel rays are incident on the mirror, they are going to meet at principal focus. How to get the parallel rays? By placing the object at infinity. So when the object is at infinity, image is formed at principal focus, which will be real, inverted and smaller in size, nothing but diminished. Second one is when the object is beyond C. As you all have seen the image formation, when the object is beyond C, the image is between C and F. How the image will be? It is real, inverted and diminished. The third position of the object is at C. When the object is at C, image is also at C, real, inverted and of same size. The fourth position of the object is when the object is between C and F, image formed will be beyond C, real, inverted and magnified. If the object is at principal focus, what happens to the image? So the rays which are passing from the principal focus, after reflection they become parallel to each other. So if they become parallel, they are going to meet at infinity. So you can say the object placed at principal focus, the image is going to be formed at infinity. The image will be real, inverted and very, very large. The sixth position of the object is when the object is between the principal focus and the pole. In case of concave mirror, object placed between principal focus and pole, the image is behind the mirror. Virtual, erect and magnified. Now we shall see the list of object and image, object distance and image nature for a convex mirror. So for a convex mirror, if the object is at infinity, image is formed at principal focus, virtual, erect and very small. So in case of convex mirror, the image formed is always virtual, as in case of concave mirror. In case of concave mirror, the image formed is real. It is virtual only when the object distance is less than focal length. If the object distance is less than focal length, image formed will be virtual. But in case of convex mirror, the image formed will be always virtual. So when the object is at infinity, image is at principal focus, virtual, erect, and very small. When the object is between infinity to pole, so between infinity to pole, wherever you place the object in front of the convex mirror, the image is going to be formed between pole and focus only, between pole and focus, and the image is always virtual, erect, and it is of a smaller size, diminished. Now how to remember this list? How to remember this list? So for that, you can consider a concave mirror. You can divide the principal axis as pole, principal focus, and C, and infinity. See, if the object is at infinity, image is at F. If the object is at infinity, image is at F. So as you move the object towards the mirror, if the object is beyond C, the image also moves away. Both object and image move opposite to each other. If the object is taken nearer to the mirror, image will be away from the mirror. If the object moves away from the mirror, image moves towards the mirror. So here we are moving our object from infinity towards the mirror, that is beyond C. So when the object is at infinity, image is formed at F. When the object is beyond C, image is formed between C and F. Image is formed between C and F. Further, we are moving our object towards the mirror at C. So our image also moves away from the mirror. So whenever we are moving our object towards the mirror, image is moving away from the mirror. Both are at C now. Now we are going to move the object towards the mirror, that is between C and F. Our image moves away from the mirror beyond the C. So as our object moves towards the mirror, image moves away from the mirror. So when the object is at infinity, image is at F. When the object is beyond C, image is between C and F. When the object is at C, image is also at C. When the object is between C and F, the image is beyond C. So in all these cases, the image formed is real. Image formed is real. And how to remember the size of the image, whether it is magnified or diminished? If it is towards the mirror, then it is diminished. If it is away from the mirror, it is magnified. So when the image is between C and F, it is diminished. When it is beyond C, it is magnified. If the image is nearer to the mirror, it is diminished. If the image is away from the mirror, it is magnified. So with this, I conclude this session, where we have discussed about the sign convention and image formation by concave mirror for different object distances, and image formation by convex mirror. So in the next session, we'll derive the relation between focal length and radius of curvature, and also will derive the mirror equation. So this image formation you try for the same object and image distances.